Hi, athletes. Today we're going to create and use graphs and equations. Josie has been walking every day and has increased her speed. She now walks at a rate of 2 meters per second. Macy has not been practicing and still walks at a rate of 2.5 meters per second. They have a race, and Macy gives Josie a 20-meter head start. Let's start by defining our variables. So when we write our equation, we're going to have an x and a y. Let x equal the time. This is going to be in seconds because we're looking at meters per second. And y is the distance. And again, that's going to be in meters because we're looking at meters per second. For Josie, she walks at a rate of 2 meters per second. So that is the time that she walks, 2 meters per second. And she gets a 20-meter head start, so plus 20. So again, this is her speed, and this is her head start. Macy walks at a rate of 2.5 meters per second, but she doesn't get the head start, so just 2.5x. Now we're going to use our equations to make a table. Here's our table. Just a reminder that x is always the first column and y is the second column. In the first column, it's our independent variable, and the second column is our dependent variable. So the independent variable is the same for both. So when we're looking at seconds, I decided to count by tens, 0, 10, 20, 30, 40, and 50. So this is independent. This is the same for both Josie and Macy, but the difference is their distance. So what I can do is for Josie, I can replace the time, which is x, with 0. So when I replace the x with 0, 2 multiplied by 0 is 0, plus 20 is 20. So at 0 seconds, Josie has a distance of 20. I can do the same thing with the 10. Again, replacing the x with 10, 2 multiplied by 10 is 20, and 20 plus 20 is 40. I continue doing that with 20 seconds, 30, 40, and 50, and I end up with 60, 80, 100, and 120. So you can see that it increases by 20 meters each 10-second interval. For Macy, I'm doing the same, but using the equation y equals 2.5 times x. And 2.5 times 0 is 0. And again, times 10 is 25, times 20 is 50, etc. And you can see that Macy's increases by 25 each time. Now let's graph this. So the title of my graph is the relationship between the distance in meters versus the time in seconds. Remember that the x, the independent, is always your horizontal line, which is the time in seconds, and the vertical line, or the y, is your dependent variable, which is distance in meters. So when I graph Josie, I start at 0, 20, 10, 40, 20, 60, etc., and I connected the points. For Macy, connecting those points at 0, 0, 10, 25, 20, 50, etc. Now, when we look at this, we can answer some questions. And we can answer the questions using the table and also the graph. So my first question is, what time does Macy catch up with Josie? Looking at the table, it's where their distance would be the same. And here their distance is both at 100, so it would take 40 seconds for them to be at the same distance, which is 100 meters. In the graph, we can look at where it intersects, and they intersect here at 40 seconds. And again, it would be 100 meters and 40 seconds. Now let's use this some more. If we're looking at the graph, I want to know what the y-intercept is for Josie. In other words, where her line crosses the y-axis. And we always write this as an ordered pair. So in this case, it's 0, 20, 0, 20. For Macy, it's right here. It crosses the origin at 0, 0. So what does the y-intercept mean in this story? Well, in this story, Josie got a head start, and that's why hers crosses at 20. Macy did not get a head start, so that's why hers starts at 0. When you look at this, which line is steeper? Well, it looks like here that the blue line is steeper, and the blue represents Macy. You can see this in the graph, but you can also see it in the equation because 2.5 is larger than 2. Now let's look at some more questions. This time, let's use the equations to solve these problems. So I want to find the girl's distance after 50 seconds. So what I'm given is the time. So I can replace the time, which is x, with 50. So for Josie, her equation is y equals 2x plus 20. I replace the 50 seconds with the x, so 2 multiplied by 50, which is 100. So it takes Josie 120 meters to go 50 seconds for 50 seconds. So in 50 seconds, she can go 120 meters. For Macy, again, I'm going to replace the x with 50, and it's 120 meters. So after 50 seconds, Macy has gone 125 meters. Now let's see how long it takes each girl to reach 80 meters. So now I'm giving you the distance. So I'm giving you the y. So with Josie, we replace the y with the 80 for the 80 meters. We subtract 20 from each side, and 60 equals 2x. So when you divide, x is 30. So Josie takes 30 seconds to go 80 meters. For Macy, again, we replace the y with 80, divide by 2.5, and it looks like it takes Macy 32 seconds to go 80 meters. So this is how you would use the equation to find not only distance but time. Now let's use our graph to solve these problems. Again, let's look at the 50 seconds. So at 50 seconds, I draw my dotted line up to see where it crosses the red line and the blue line. And on the red line, it crosses at 120, which is what we got from our equation, 120 meters for 50 seconds. For Macy, with the blue line, it's 125 meters. We can do the same with 80 meters. So at 80 meters, again, where it crosses, we drop down, and it takes Josie 30 seconds and Macy 32 seconds. So again, you could use the equation or you could use the graph. The equation is going to be more accurate than the graph, and again, depending on the intervals that you use in the graph. All right, now let's try and write a different equation. For this one, we want to write an equation with the slower walking rate, but a larger head start than Josie. So Josie's walking at a speed of 2 meters per second. So I need to think of a number less than 2. There is an infinite number that we could use. Notice I did not put a number in front of x, and that number is understood as a 1. So 1 is less than 2, so this means that she's going to be walking slower. For a greater head start, it would be any number greater than 20. So I could do 21, 1,000, 1,000,000. There's an infinite number that we could use. I chose 60. So let's graph this and see if it looks like she gets a head start and at a slower speed. So you can see her head start is at 60, so she definitely got a bigger head start than Josie did or Macy. And you can see that this line is less steep than Josie's, which is the red one. So that means she's walking at a slower rate. I hope this helped you with using tables, graphs, and equations for solving problems. And thank you so much for watching.